A very good afternoon to everyone, and on behalf of the Indo-German Chamber of Commerce, and I greet you and all the guests and participants of today's webinar, together with our friends and our knowledge partner from Evonik India, on this very important topic that we're covering today, which is called Circular Plastics Enabling Next-Gen Solutions. So I guess we're all very much looking forward to the presentation. Just starting a little bit with a very short introduction. I don't think that Evonik actually does need an introduction. It's one of the world's largest specialty chemicals companies, and I'm referring to the 2021 numbers that I have seen, 33,000 employees in 27 countries and global sales of about 15 billion euros. As such, Evonik has been very much focusing on the topic of also approving and implementing strategies of for circular economy, circular plastics supply chain, to show also that the topics of sustainability and innovation are basically two sides of the same coin. I think this is something that Dr. Patrick Gloeckner will introduce to us today, and also elaborate upon the program, the challenges and the opportunities, Evonik's various technologies in that area. And I would like to continue with a short introduction. Dr. Patrick Gloeckner is the head of the Global Circular Plastic Program of Evonik. He's driving the activities around the plastic recycling across the group. And his and the current role that fits perfectly to his passion, and that is setting up of ecosystems along the complete value chain and enable circular plastics in a wide range of applications. He is a polymer chemist, has 20+ years of history in the chemical industry, taking on different roles in the business and innovation. He represents Evonik in several international and national associations, and he earned his PhD from the University of Mainz. He is, as he says, always excited to discuss work and ideas and innovation with passionate engineers and scientists, and I'm sure that we have some of them in our call and in the webinar today. So we're very much looking forward to the presentation and also then the following discussion. And with that, I would like to hand over to Patrick. So please, the floor is yours.
Yeah, thank you, Stefan. Really an honor to be here, and it's also a wonderful opportunity to talking about our circular plastics with you guys. So we call the presentation "Circular Plastics Enabling Next-Gen Solutions," and what's behind this I would love to tell you in a minute. However, when we are talking about circularity, circular economy, it's of course a kind of transformation of the industry. So we see that the transformation has started in several countries all over the world, but it's of course a starting point, and we will meet over the next couple of years several challenges, and we will have to overcome several hurdles to really come towards our circular economy. And I want to inspire you a little bit what we are doing at Evonik. And Evonik, Stefan mentioned it already, is a specialty chemical company, which is a global company, more than 30,000 people working for Evonik. Last year we had sales of more than 18 billion euro. And we are a specialty chemical company. This means we are pretty much focused on R&D and try to help our customers along value chains to really innovate, to really successfully overcome specific hurdles. A specialty chemical company means that our products are not in a B2C business. This means we make products better with our additives, with our products. For instance, in the field of tires, you can't buy a tire from Evonik, but when you buy a tire, you can be sure that a product of Evonik is in, for instance, to make the tire more fuel efficient, so lowering the fuel consumption. You don't be able to buy a mattress of Evonik. However, we have added that help during the foaming process of a mattress to make bubbles of very evil quality on the one hand, and on the other, the bubbles are, depending on the wish of the customer, big or small, or open cell bubbles or closed bubbles. And this means you can somehow or influence the boundary effect, and this means the flexibility of a mattress. We don't produce tablets. In some cases, we produce the active materials, so the active pharmaceutical ingredients. However, what we really do is we help to bring the API to the right place of the body. So, for instance, we have drug delivery systems that help to the IPA to go through the gut or through the stomach to the gut, and then we have a specific release profile so that the API is released over a specific period of time. The benefit for you as a patient is that you don't need to eat a tablet every 2 hours or something like this, but maybe just one per day, or even one within 1 week. Evonik is strongly committed to the UN sustainability goals, sustainable development goals, and we identified the most important ones and clustered it in 4 different areas for Evonik, and we said, okay, we can contribute to climate change, fighting climate change. We are able to ensure health and well-being. We are able to help to safeguard our drive circularity, and this is what we are talking about. I don't know what happened here, and we are driving our circularity, and therefore we are contributing with the slogan "Leading Beyond Chemistry to Improve Life Today and Tomorrow." To bring it in a more solid way, our vision is to really help our customers along value chains to become more sustainable, or we call it handprint. And with our enabling technologies, so additives and specialties, we help our clients and customers significantly to lower the carbon footprint. This means we have our product portfolio put into the next gen solutions in order to really provide our clients leather to reduce their carbon footprints. At this point in time, we have identified more than 50% of our product portfolio sales that are contributing as really top performers towards the handprint of for our customers, and we will advance our product portfolio until 2030 significantly. In addition, we are also contributing and are very committed to the Science-Based Sustainable Target Initiative, and therefore we also try to reduce the carbon footprint of our own technologies by 2030. We want to reduce the scope 1 and scope 3 emissions to 25%. And in order to do so, we are investing more than 4 billion euro until 2030 in the next gen solutions and technologies. One important pillar of this strategy is to enable sustainable plastic value chains. So we help our customers to meet the challenges, to overcome the hurdles of a circular of the transformation towards a circular economy. And this is what we are really doing in several different projects and in several different actions within our clients every day. So in a linear value chain, everything starts with the mineral oil. And along that value chain, refinery process, monomer manufacturing, polymer manufacturing, and so on, we have today many different products that are contributing. Adsorbents, catalysts, our additives, but also several polymers we are producing by ourselves. And along that value chain, we have our significant impact on the production and products of our customers. After the use phase, the products are usually put into the waste management system and some either incinerated or put into the land, so landfills. And in a circular economy, we want to change it. We want to have to keep the material as long as possible in the loop. And this is the reuse. And then when it's not possible anymore, we do mechanical and chemical recycling. And we have several specialties that help the process to make the processing of the recycling process more efficient and the quality of the recyclates better. In addition, we consider also improving the durability and enabling design for recycling concepts as part of our circularity ambition. And therefore, we also contributing a lot to help our clients to make products more durable and the design for recycling concepts possible. What does it mean? So, for instance, we have our many different products that are used in wind blades. So what we are doing is, for instance, the coating, and we provide the aliphatic cross-linkers with best weathering resistance, so that the rotor blade is covered, and the weathering resistance provides higher durability. However, we also provide foam material which is used in the core of the wind blade for stability reasons. And this foam material is based on polymetacrylate chemistry, and we are able to do the recycling as well. So the foam material itself is recyclable. This is one example of what we considered as kind of design for recycling, and this is another example. We in our portfolio is polyamide 12, and polyamide 12 is one of the let's say highest performance polymers, thermoplastic polymers, and we try to think about a little bit out of the box. So we said, okay, what would happen when we designed a seat for a car completely made from polyamide 12? And usually a seat contains 15 to 20 different kinds of polymers, so polypropylene, polyurethane foam, PET, textiles, and so on. And we said we want to replace all the different materials to provide a monomaterial seat. And we did, and the result is shown here. The foam material, the textiles, the frame, everything is made from polyamide. And the reason why we did it is relatively simple. You can remove after the use phase this seat and put it into a mechanical recycling process without any separation of different materials anymore. And this, of course, is a great opportunity. However, it's for inspiring. So we want to inspire OEMs, not only in the automotive OEM industry, but also in other industries, to making sure that the design for recycling aspect can be considered in other products as well. And I brought you one example, which is a little bit easier. And this is a toothbrush. And this toothbrush is made from polyamide 12 as well. So everything is polyamide 12, and this means you can easily recycle it. However, like always in a circular economy, you need to consider that you have a reverse logistics. So that means after the use phase, we need to establish a kind of our collecting system so that we can get the material back. And this is something which is very important to understand, that in a linear value chain, so make, use, dispose, nobody takes care of the waste anymore, or at least the ones that are in the early beginning of the value chain. And this is different in a circular economy, because this material needs to somehow brought back into the plants, and this means we need to partner along the value chains to closing the loop. Mechanical recycling is one of the most efficient recycling processes of plastics, and of course our role as a specialty chemical company is not to doing the recycling process by ourselves, but helping the recyclers to making the process more efficient. So we have additives for washing, for separating by flotation, for the drying process to make the washing more efficient and the quality of the recyclates better. In addition, we are able to increase the quality of the recompound significantly by our products. So for instance, very often you have different fractions of polymers that are not compatible to each other, and we are the ones who brings the compatibilizer in, so that the quality and the performance of the recompounds are significantly better. So in a nutshell, we help our clients to make to reduce the costs and increase the quality, and this at higher recycled content levels. Just to inspire you a little bit what we are doing, and this is one example of flexible films. You have often a printing ink on it, and we have the additives that help to remove this printing ink completely and fast. Completely means you save the color is reduced significantly, and this means a colorless recyclate can be used for different applications, so it's a kind of higher quality recyclate. And on the other hand, we help to do this process fast, and this means you save costs. And this is possible in case of printing inks, like on flexible films, but also on rigid or flakes as well. I mentioned that we have to partner along value chains, and this is really the most exciting difference to a linear value chain, because we need to understand the different challenges at one specific stakeholder in order to overcome hurdles. I'm really proud that we started an ecosystem with BMW, and we take care of recycling of bumpers and other components of a car that are made from plastics. And of course, our role is to providing the additives to making the recycling process more efficient and the quality of the recyclates better by discussing with the recycler. So helping to decode, to remove the coating from the bumper, for instance, but also to helping the compounder to meet the requirement profile of BMW. The project started last month, and it will take some years. However, we are really optimistic to meet all the different challenges. And the good thing is, when we see some hurdles, we can also discuss with the OEM, hey, is it a good enough quality for specific applications, or is this something we need to improve even further? And collaboration means you can really openly and trustfully discuss in this ecosystem the challenge you are having. So I mentioned in the early beginning of my presentation that we are working also in the field of PU matrices. So the mattress market for us is really important, and we took the responsibility and said, okay, let's develop a recycling process for polyurethane mattresses, and this is shown here. So we are able nowadays to use the used mattresses to convert the polyurethane foam into monomers. This means the repolyol and the amine, which are the main components of such a polyurethane formulation. And this is a chemical recycling process of really a very challenging recycling process. And we are really proud that the polyol, for instance, can be used by 100%, and the performance of the foam, the mechanical properties are more or less the same compared to the virgin polyol. However, you can see the color is slightly different, and this is something we need to work on. However, in the end, as it is 100% repolyol, you can, of course, claim that the greenhouse gas emissions, the carbon footprint is significantly lower, up to 60%, according to our life cycle analysis we made from our, let's say, pilot plant process. In addition, using the waste as a feedstock means the waste is significantly reduced, and this is circular economy. You use the waste as a feedstock to produce new products out of it. And this is also the concept by using mixed plastic waste, which is not suitable for mechanical recycling. So what we have seen so far, mechanical recycling is the most cost-efficient process to recycle thermoplastic waste streams. However, when it comes to mixed plastic waste, when it comes to plastic waste which is contaminated somehow, you can't do mechanical recycling in a very economical and ecological way. And therefore, a good complement technology is the pyrolysis technology of those materials. And the process is relatively easy on the paper. In reality, it's really challenging because of the challenging plastic waste feedstock. So the plastic waste is converted in a liquid pyrolysis oil, and this pyrolysis oil is intended to be used in a steam cracker to replace fossil naphtha. The steam cracker produces olefins, so ethylene, propylene, butadienes, something like this. What we have seen so far is, I mentioned in the beginning, that the process is on the paper relatively simple, in reality a challenging process because of, for instance, the contaminants. You have several different contaminants, chlorides, for instance, in the pyol that needs to be removed before the pyol is managed in the steam cracker, because chlorides, for instance, are causing corrosion issues. And we have exactly the technologies at Evonik to removing contaminants significantly. It's hydroprocessing catalysts, adsorbent materials that are used to upgrade the pyols, making them suitable for the steam cracker. And then, of course, you can replace the fossil naphtha. In addition, we have several other additives that are used to make the pyol, for instance, more flowable or the storage stability better. This is a typical pyol after it is liquefied, and we are the ones who are really removing the color. We are the ones who are really removing contaminants and therefore odor, and the result is a very pure py wax in this picture. But I said the pyrolysis oils are managed in a steam cracker to produce ethylene, propylene, and butadiene. And Evonik is, of course, also our off-taker of those materials. that are used, for instance, to produce polyamide 12. And this is one example what we are doing. We use the butadiene coming out of this steam cracker process, and we use the pyols in a mass balance approach to really provide polyamide 12 elastomers, for instance, with a recycled content of 50% based on the pyrolysis oils our suppliers are using. And this reduces the product carbon footprint significantly. Important is to mention that we are also using renewable energy to produce those polyamide elastomers. And these materials are used then, for instance, in such shoes. So in general, the quality is absolutely identical to the quality of the fossil polyamide 12 elastomers. However, the product carbon footprint is lowered and the recycled content is significantly increased. And with this, I would love to end my presentation. Whenever you have questions, whenever you are interested in discussing with us, so I am located in Germany, and my counterpart in Mumbai is Srini Bazar, and he's really excited to talking with you about circular economy in India. So thank you for your attention, and I would love to end with a number of poll questions to get let's say an overview about your challenges and also the speed of transformation towards a circular economy in India. Thank you.
Meanwhile, may I please request all the participants to place their questions in the question box or the chat box, and we will take your questions during the Q&A round after the poll session is over. Thank you. Here are the results for the first poll. Patrick?
So at this point in time, it's very small for me. I can't read it.
Oh. We have 63% of the participants who've selected option 1. Yes, India will be leading the global transformation. 36% who have opted for question 2 for sure, but it depends on the country, and only 1% for not at all.
That's really exciting.
We have the second poll up. You have the result for the next poll. 59% of the audience, they've selected only way to balance economic growth and environmental population, which is the highest. Second, 19% have gone ahead with the end consumer pull for more sustainable products.
More importantly, Patrick, circular economy will not play a role in India is zero.
Yes.
And although the monitor is very small, I am really excited because it shows the potential that the circular economy has in India. And this really will certainly help the transformation process globally.
Yeah.
I wished I could enlarge the monitor somehow to make it more readable.
You have the third poll. What is the most important challenge to increase circularity in plastics? You have the result of the third poll. We have 76% of the participants who have gone ahead with the first option, which is infrastructure for collecting and sorting of plastic waste. Rest 11% have gone ahead with quality of the recyclates, 10% cost, and 3% for demands from brands and OEMs.
This is also very exciting because it shows that we need to give the plastic waste a value, and then our collecting and sorting will somehow manage by the located infrastructure companies in order to sell products. So business relevant value is important here.
Correct. Here we have the second last poll. For which application do you plan to use mechanical recyclates? Okay, so 59% have gone ahead with packaging plastics and 41% with engineered plastics.
This is somehow surprising because I thought that packaging plastic is easier to recycle because it's simply a bigger volume. However, it's exciting because it means that especially improving specific performance criteria are the most important in engineering plastics.
Here's the last poll of the session. How can the scale up of chemical recycling being accelerated? We have the maximum vote of 49% for technology, then 34% for progressive legislative framework, 11% grants from government, and 7% customers who are willing to pay a premium.
Quite interesting. And this means it's good that we are talking about and that we give this presentation, because we are now approachable, we are now visible to you guys. And this means it would be really our pleasure to talking to you about our technological solutions and how we can jointly improve our recycling processes. Thank you so much. But the answers make me really optimistic that we really can do the transformation towards a circular economy of plastic.
Now we will quickly go ahead with a short Q&A round. Okay, so the first question what we have here is, what is the best solution for mixed plastics? Why? And what is the economical viability of such projects?
So I showed in the presentation the pyrolysis technology. So pyrolysis technology is good for our mixed plastic waste streams that have a high content of polyolefins, so carbon hydrogens. And this is, from my point of view, the most important technology that will be scaled up globally within the next 5 to 10 years. So we see all over the world that companies, especially petchems, are working on projects to make the recycling process, the pyrolysis process, commercial available. And they have investment projects started to have a first commercial plant available by 25 to 26. And this will be for sure only one step, and the second step towards 2030, when, especially in Europe, regulatory challenges will become effective, or will result in further plants all over the world. The challenges are at this point in time for sure to scale the processes, number one, and number two, to make the resulting pyrolysis oils suitable for the steam crackers. And this means we need to remove all the contaminants, including chlorides, including metals, silicons, stuff like this.
Thank you. Going ahead with the next question, what are Evonik's long-term goals and supporting plans to invest in chemical recycling in India?
So we will never, that would be my question today, no? Or say never, never. But at this point in time, we would not invest in chemical recycling by ourselves. However, we would help our customers to improve the processes and make the processes are running well. So with our competencies, with our technology know-how, but also with our product know-how, we would help our customers and partners along the value chain to make the recycling of and including the chemical recycling of our plastics cost efficient, and the quality of the resulting products better. And here, of course, we invest a lot in our several projects, R&D projects, as well as from our process, where our process engineering teams are strongly involved to come to suitable solutions for our customers. However, our role is specialty chemical company, And this means we stay in our strategic role as our specialty chemical company, and this means solution provider.
Sure, thank you. Does Evonik plan to set up comprehensive recycling infrastructure for plastics recycling, reuse engineering, packaging, specialty, etc.?
So we of course inspire our customers and partners to do so, and we working strongly with our partners in projects to setting up such ecosystems. However, circular economy means you need to bring in your competencies and your capabilities, and the other partners need to be selected to really closing the loop. And therefore, it's important that partnerships are set up where complement know-how is put together to really come to our suitable solutions cost efficient.
Thank you. The next question is, how many cycles we can recycle polymers?
Polyamides or polymers?
Polymers.
Polyamide.
Okay. We did it in a test study. Now we did it 7-8 times without reduced performance properties. However, we know that there is a limitation in cycles because mechanical recycling means you bring in a lot of energy, and this will cut the polymer chains a little bit, reduce the polymer molecular weight, and this finally will result also in lower properties. And this means after 8 to 9 cycles, the better solution would be monomer recovery, or that would be my preferred way of managing then let's say the used polyamides.
Patrick, your voice is breaking. Sorry,
And
we cannot hear you.
Same, you can find studies with polypropylene or polyethylene, and here the number of cycles is limited to 5 to 6 cycles. I have nothing changed.
Can you hear me? I think there's a slight lag.
Yes, I can
we are
hear
not
you.
being able to. Okay. Okay. Next question: how effective the wetting agents will act in case of PP and PE, since both densities are close to each other?
So in general, the tensides are used to reduce surface tension, to making sure that the water can remove the dirt, greasy stuff, and printing inks well. They have a slight impact on the flotation process, because whenever you have bubbles on the surface, then the flakes are swimming at the surface of the washing bath. So it's a flow sink bath, and due to the tensides, the bubbles are removed completely, and this means the polypropylene is sinking down, while the polyethylene, especially the LDPE, is swimming at the surface, and then the separation can be done in a very proper way.
Okay. Does Evonik plan on having training programs for potential partnership plans in India?
So in general, this is one important role of Evonik, that we are discussing with our technical service manager teams the processes of our customers, and we help our clients to improve their processes with, and part of the business is of course to provide our knowledge. Of course, under an NDA, and when we're talking with one customer, we do not take this knowledge to bring it to another. That wouldn't work. So we are, of course, reliable, and our reputation is well known in the market.
Thank you. Do Evonik's technologies deliver significant cost savings to OEMs? How exactly?
I would say it depends. So in general, our products are used in the different areas of OEMs. So I would defer the brand owners, which are dealing with packaging plastics, from the OEMs that are dealing with the engineered plastics. And here we can discuss, of course, on the one hand, when they want to increase the recycling content to gaining access to high quality recyclates for a good price, performance ratio. However, this would be the discussion, of course, between the recycler who is providing the recyclate and the supply chain towards the OEM on the one hand. On the other, we are, of course, a provider of polyamide 12 and polymer foams, the high performance polymers. And here we can definitively help our clients to understand where costs are can be reduced by using our materials instead of others to replace them.
Thank you. Our next question is, can you touch little about quality check post process?
What? I couldn't hear it.
Quality check post process. Can you touch upon the quality check post process?
So I'm not sure if I understand this question correctly, but in general, so I'm trying to translate it in my process understanding. So when a recyclate it needs to be used, or you need, of course, to do some tests, including odor tests, including the color tests, and also to do simple tests with regard to melt indices, so melt index. And what we see is when you get a package of recyclates, the quality is not consistent, but in different areas of this package, you have different recyclates, and therefore you need to do the quality check very in different from different parts of this package, to making sure that you analyze that you cover the average quality of this package.
Can Evonik technologies be useful in cleaning of legacy plastic waste at municipal dump sites and sanitary landfill facilities?
So yes, absolutely. I am struggling a little bit because it would mean you need to setting up a really huge project with several with many diverse partners to doing so, and that would be really the challenge. But in the end, once you have removed the plastic material and selected from that feedstock, of course, we can help to do the cleaning process in a proper way.
All right. Okay. Whether technology for color and odor removal of wax fractions can be used for other waxes as well?
To be honest, the technology was developed for the petrochemical industry, and we identified that this brings value to the circular, to the pyrolysis processes as well. So it's really a industry cross innovation we did. However, yes, we have many decades experience in the fossil and petrochemical industry.
Okay, now going ahead with the last question. Please guide us on how we can encourage our suppliers for adoption recyclable plastic packaging. Suggest mechanism for the same.
Yeah, it's really partnering along the value chain. So I assume you are, for instance, a converter, and you need to identify the right suppliers that are able to provide the right quality of recyclates, and this is one part. The other is you need also to engage the brand owners and OEMs who are willing to increase the circular content in their materials, in their packagings, for instance, and this means to setting up ecosystems. So partnering along the value chain is really it's easy said. However, the challenge is to bring all the different players together. What we have seen in several partnerships we have set up so far is that it is always good to convince the OEM and brand owner first, and then select jointly the other partners. So this is something we are doing, and as Evonik is along the value chain are well known because we have business with all the players along that value chain. It's relatively easy for us to identify also the right experts, the right decision makers in the different companies to really closing the loop. But this is the difference to the linear world, where it is probably good enough to talking to your supplier and to your customer. Or in a circular economy, you need really to think holistically.
Thank you so much, Patrick. For our participants, in case you would like to connect with the speakers directly, their email IDs are here visible on the screen of Dr. Patrick as well as Mr. Rao. You may please note down their email IDs and please feel free to write to them in case you have any queries or if you would like to connect with them for your requirements. And now, on behalf of the Indo-German Chamber of Commerce, I would like to express our heartfelt gratitude to Evonik for their invaluable contribution to the seminar. Thank you so much, Patrick. It was an extremely insightful session. It was an honor and privilege to have you as a partner, and your support was instrumental in making this seminar a success. I would also like to extend our thanks to all the participants who attended the seminar. We hope that you found the discussion insightful and valuable. We would like to inform you that the recording of the webinar will be uploaded on our IGCC website, Indo-German Chamber of Commerce website, under the event section. So for those who are unable to attend or would like to go back to the presentation, you can anytime log in and listen to the session again and benefit from the knowledge and insights shared during the seminar. And once again, thank you for your support, and we look forward to interacting with all of you again in the future. Thank you so much.
Thank you so much.
Yeah, thank you, IGCC as well.
Thank you. So with this, we will end the session now.
Thank you, Sana. Thanks, everyone. Thanks, IGCC team, for having us today.
Thank you, Samriddhi. Thank
Yeah.
you so much.